in this example, we are going to be looking at how to calculate the molar mass of aluminum nitrate. So this is a question that you might be asked where you're first given the name of a compound, and then you first need to figure out the formula before calculating the molar mass. So a good review from our first unit. So we know aluminum is Al, and we know that nitrate, if we look on our common ions chart, we know that nitrate is NO3 minus. We also know from our common ionic states of the elements that aluminum has a 3+ charge. So we've identified our two ions there, and we can then crisscross those to figure out the compound's chemical formula. So I will rewrite the Al and then the NO3. Crisscross them, that gives us 1 aluminum and then 3 nitrates, which we would rewrite as being Al, NO3, 3. Alright, so we've identified our chemical formula. Now we can start to figure out the molar mass. So to be able to find the molar mass, we first have to identify the number of atoms of each element in this compound. So we see AlNO3 with the subscript 3. So let's count out how many atoms there are for each element. So we have aluminum. We know there is 1 aluminum. And then let's look at nitrogen. So for nitrogen, there's 1 nitrogen in a nitrate, but there are 3 nitrates. And that tells us that there are 3 nitrogen atoms. And then for our oxygen, there's 3 oxygens in a nitrate, but there are 3 nitrates in this compound, so that means there are 9 oxygens. Alright, our next step is we need to figure out the molar mass, also known as atomic mass, for each of these 3 elements. And where we go to do that, we would go to our periodic table. So we know we're looking for aluminum, we know we're looking for nitrogen, and we know that we're looking for oxygen. So here is the molar mass or atomic mass of aluminum. There's nitrogen, there's oxygen. So we know that for aluminum, it is 26.9815 grams per mole. That's the molar mass of the aluminum. For the nitrogen, we know that it is 14.0067 grams per mole. And then for the oxygen, we know that that one is 15.994 grams per mole. So we've found the molar mass for each of the atoms on their own. But now we have to make sure that we're multiplying by the number of atoms in the actual compound, because each atom of aluminum has this mass, each atom of nitrogen has this mass. We're assuming a 1 mole sample. So that means the actual final molar mass for each of these, that one would be for the aluminum, right? We know that there's 1 aluminum, so that's going to be times 1, times 3 for the nitrogen, and times 9 for the oxygen. So this one there, that's going to end up being the same for the aluminum. The molar mass of the nitrogen times the 3 nitrogens. That's going to be the molar mass of this compound from the nitrogen. And then for the oxygen, 15.9994 grams per mole times 9, because there's 9 oxygens, 143.9946 grams per mole. Notice here how I'm not rounding anything yet. I want to carry as many decimals as I can until the very end of the question, so we get the most accurate answer. So now you'll see here, we have calculated the molar mass for each element within this compound. And then what we do to get the final molar mass, we are simply going to add all of these together. So I recommend having a really good scientific calculator with you to make this a really quick job. And then when you add these three values together, you will get 212.9962 grams per mole. Or if we were going to round this, we can just round it to 212.996 grams per mole. That just keeps it consistent with what's in the periodic table. Oftentimes, it's fine if you just round things to 2 decimal places. So that's the molar mass, and then to finish off this question, therefore, the molar mass of aluminum nitrate is 212.996 grams per mole. And there we have it. We have now a complete solution for the molar mass of aluminum nitrate. So, paying attention to all the work we had to do, we had to figure out the molar masses for each element on their own. We also had to determine the formula, and then we determined the final molar mass, plus a therefore statement. On maybe a test, I would always tell you if I expected you to show all your work, and there would be marks associated with each step, or sometimes it will be appropriate just to provide the answer. But you'll always be told what you need to do.